In this video, we're going to discuss examples using the factor theorem as well as the remainder theorem. So let's take a look at this first example. We're asked to find f of -4 when f of x is x to the third plus 9x squared plus 36x plus 52. Now, previously, we likely would have just tried to input or substitute -4 everywhere we see an x. Now, that may be a bit longer or a bit more tedious because we would have to do -4 to the third power, here -4 squared, and then times 9, here -4 times the 36, and then add all those together, and then eventually come up with an answer. But we can use what's called the remainder theorem. And in the remainder theorem, we're using synthetic division to help us find the answer to f of -4. So let's go ahead and give that a try. So we're going to use -4 inside of the box, right? Because that's the value that they give us. And just like in normal synthetic division, we're going to write all the coefficients of this polynomial function. So we see that there's an invisible 1 there, so I'll do +1. The next one is +9. And notice that I don't have to add any placeholders because it's going in a descending order. There are no exponents that are missing. So +1, +9, +36, and +52. I draw my line and then I go ahead and begin. Remember, in synthetic division, the first value is always brought down below the line. And now we multiply 1 times -4 is -4. 9 minus 4 is +5. 5 times the -4 is -20. 36 minus 20 is +16. 16 times -4 is -64. And then lastly, -64 and +52 result in a -12. So it's called the remainder theorem just because of that specifically, that word remainder. In the synthetic division, there is a remainder at the very end. For us, it's a -12. So that'll be our answer. We can write f of -4 is equal to -12. If someone else were doing the problem and they wanted to check, they could go ahead and input -4 everywhere for an x, do that computation, and they would still come up with -12 as we did here. So again, this was the remainder theorem. All right, let's take a look at another problem. This time we're going to use what's called the factor theorem. Right? This is called the factor theorem. We're told to determine if x plus 4 is a factor of x to the third plus 3x plus 76. So to determine if something is a factor of something else, then we must make sure it divides evenly. For instance, I can tell you that 4 is a factor of 20, right? Why? Because 4 goes into 20 5 times evenly. There's no remainder there. So therefore, if I complete some division, and I'll use synthetic division in this one, and I divide x plus 4 into this entire polynomial and get no remainder, then that tells me x plus 4 is a factor of this polynomial. If I did this division and do get a remainder, then of course it's not a factor because things are only factors if they divide evenly. So x plus 4. If you recall from our initial synthetic division lectures, that when we had the divisor, we would always take the opposite of that constant. So we're going to use -4. -4 goes in our box. And now we're going to say to ourselves, what's the coefficient in front of the x to the third? Well, we know there's an invisible 1 there. I don't see an x to the second term, right? So therefore, I have to use a placeholder of 0. I do see x to the first, so I'll use that +3. And then I see the constant, which comes after the variable term of 76. Now I'll draw the line and do my synthetic division. So I drop the 1 down, all the way down below the line. +1 times -4 is -4. 0 and -4 is -4. -4 times -4 is +16. 16 and 3 make 19. And then lastly, 19 times this -4 gets us -76. +76 and -76 make 0. So the key thing to look at here is our remainder. In synthetic division, the remainder is always this last value. And as I stated a few moments ago, for something to be a factor of that something else, it must divide evenly, meaning have no remainder. So therefore, this is 0, the remainder. Our division has no remainder. So therefore, we can say, yes, x plus 4 is a factor. And it is a factor of x to the third plus 3x plus 76. And why? It's because it went evenly into x to the third plus 3x plus 76. We saw that the remainder was 0. If the remainder was anything else but a 0, we would write no, that it is not a factor. Preceding this lecture, it may be a good idea to watch the one on synthetic division. And go over in synthetic division is good to have something that you master before coming into these two areas of the remainder theorem and the factor theorem. All right, remember to like the video, share to whomever you need to, and subscribe to the channel. Thank you very much.